All right, Advent of Code 2018, day 14. It's called Chocolate Carts. You finally have a chance to look at all of the produce moving around. Chocolate, cinnamon, mint, chili peppers, nutmeg, vanilla. Elves must be growing these plants to make hot chocolate. As you realize this, you hear a conversation in the distance. When you go to investigate, you discover two elves in what appears to be a makeshift underground kitchen laboratory. Elves are trying to come up with the ultimate hot chocolate recipe. All right, even maintaining a scoreboard which tracks quality score 0 to 9 of each recipe. Only 2 recipes are on the board. The first recipe got a score of 3, the second 7. Each of the 2 elves has a current recipe. The first elf starts with the first recipe and the second elf starts with the second recipe. Okay. Smab says chocolate charts. Oh, did I say chocolate carts? Sorry. Yeah, chocolate charts. All right, to create new recipes, the 2 elves combine their current recipes. This creates new recipes from the digits of the sum of the current recipes' scores. With the current recipes' scores of 3 and 7, their sum is 10. Okay, and so the 2 new recipes we created, first with a score of 1 and the second a score of 0. Okay, splitting it up. If the current recipe scores were 2 and 3, sum 5 would only create 1 recipe with a score of 5 with its single digit. The new recipes are added to the end of the scoreboard in the order they are created. So after the first round, the scoreboard is 3, 7, 1, 0. After all new recipes are added to the scoreboard, each elf picks a new current recipe. To do this, the elf steps forward through the scoreboard a number of recipes equal to 1 plus the score of their current recipe. So after the first round, the first elf moves forward 1 plus 2 equals 4. This doesn't seem like the optimal way to find the best recipe, but let's keep going. 1 plus 3, because 3 was their original one, and we're adding 1 to it, and we get the 4th recipe, or he steps forward 4 times, right? So I'm imagining they're going to loop. Second elf moves forward 8 times. If they run out of recipes, they loop back. Yeah, okay. After the first round, both elves happen to loop around until they land on the same recipe that they had in the beginning. In general, they will move to different recipes. Okay. Drawing the first elf as parentheses and the second elf as square brackets, they continue this process. Boom, 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 boom. And we got these numbers highlighted here. The elves think their skill will improve after making a few recipes, your puzzle input. However, that could take ages. You can speed this up considerably by identifying the scores of the 10 recipes after that. So the ingredients don't matter, right? It's just, all right. I'm not going to go too deep into it. So this is fixed, right? So this is the number of recipes we're making is my puzzle input, which is 939601. So this sequence is going to be fixed. Everybody who's writing this code is going to have this sequence of numbers. And so these values, okay. So we could just write a little program which does this work. And it says, what are the scores of the 10 recipes immediately after the number of recipes in your puzzle input? Okay. So after making 9 recipes, the scores of the next 10 recipes after the first 9 on the scoreboard would be 5, 1, 5, 8, 9. And that's what this highlighted thing is here. So we have to generate up to this many recipes plus 10 more, and then take those digits and print those out. All right, that doesn't seem too bad. I'm scared about what part 2 is going to be then. All right, let's do our template. And then we do this. And we do this. Try to build it. Hit run. Unsolved, unsolved. Perfect. All right. So we have, I should have grabbed my test input, or my puzzle input, because that's hard-coded. P count. U size. I guess these are all going to be U sizes. All right, that's a good start. Now what? I guess we can create a vector of recipes. And we always start with 3 and 7. We have elf1 starts at location 0 and elf2 starts at location 1. And now let me see these rules again. The two elves combine their current recipes. I'm just going to write this out and then we'll put it in a loop in a second. So new recipe is equal to recipes of elf1 plus recipes of elf2. And then if it's greater than 9, we're going to do 1 plus the last. We're going to push a 1. I'm trying to think of is there an easy way to do that, but I don't think I'm going to go too much into it. So new recipe is greater than 9. Recipes push 1. And then recipes push new recipe mod 10. Great. Output unsolved. That way the warning goes away. Oops. I forgot how to spell the word recipes. There. Right? It's R-E-C-I-P-I-E-S, right? Oh, no. R-E-C-I-P-E-S. Okay. That's what it should be. There. Okay. So we don't have an answer yet because we're not doing anything. But now, chat says... Chat _ says hello. I got to say the __, right? Otherwise, it sounds like I'm just talking about chat in general. That's great. All right, so now we need to move the elf, right? Each elf moves up forward by the score, 1 plus the score of their current recipe. So we just need to rotate it. So elf1 is equal to recipes of elf1 plus 1, but then mod the length of the recipes len, right? And then elf2 has the same. All right, let's loop this. But we're going to loop until when? Oh, and until we hit 10 past our recipe count. So while recipes.len is less than self recipe count plus 10. Right? Is this all this is? Because then this is going to be an easy day 14. Oh, maybe part 2 is going to be more annoying. Let's find out. And then all we need to do is print out all the digits in recipes from the recipe count on, right? So we could just collect those. For C in recipes of self recipe count, because we've gotten all 10, right? Let mut answer equals string new. And these should all be digits, right? So we can say answer dot push C plus C as U8 C as U8 plus 0 as char. And then we can just dump that. Oh, I don't want to modify this thing. I can't iterate over a slice? Oh, I have to put a thing here? C as U8. I'm guessing that's wrong. I don't know what I did wrong, but I'm guessing that's wrong. Let's print out the first, what do they have? The first 20, and we can see how poorly I did. Let's change this to 9 real quick. Semicolon // Yeah, obviously there's a bug here somewhere. What did I do wrong? I mean, I'm adding up the sum of the two recipes. If it's greater than 9, we push the 1, and then we push the next digit. We move to the next ELF. Smab says, that's wrong. I've run your input through my code. Yeah, this just looks completely wrong. So let's find out what I did wrong. So after each one, I should be able to just dump out the recipes. Right, and we can see where I went wrong. What are these values? Oh, look at that. 37106, right? I'm getting a 6 here, and it shouldn't be a 6. It should be a 1. All right. So, given that, what are we doing wrong? I mean, we grabbed the new recipe. We got the 1, 0 correct. The new ELF locations must be in the wrong spots. So let's print those out too. ELF1 and ELF2. And here, after the first round, elves should be at 0 and 1 again, right? And they're at 0 and 0, 4 and 4. Whoa, 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 whoa. What? Okay, I mean, that's obviously the bug. All right, so this says while recipes len is less than self recipe. That just says how many loops we're going to do. The new recipe should be 10. Right? And now it's saying this new recipe is 6. Because ELF1 and ELF2 end up at 0 and 0. But they should end up at 0 and 1. Recipes of ELF2 is 7. Plus 1 is 8. Oh, yeah, and 8 mod 4 is... Oh, do I have to use the previous len? I bet you I have to use the previous len. No, that doesn't make sense, right? Yeah, it's the current position plus... Got it. There we go. And now it's 515, blah, 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 blah. Got it. Okay. And now if we just do it for the real amount, we should have an answer of this. Right? And this should be right. This has got to be right. Should I do a poll? I'm not going to do a poll. I don't do polls. That's the right answer. Yay. Okay. All right. That was easy enough. That's an easy enough part 1. Let's check in with Clippy. This map gives me a star too. Thank you. Oops. I keep doing that in the wrong window. Okay. So Clippy's happy. We're going to quit out here. Git status. Git add source. Git commit -am 2018 day 14 part 1. That was a lot easier than yesterday's part 1. What do you think? If part two might be one of those things where, you know, now what's the billionth recipe or something like that, and you have to figure out how to there's loops or there's some optimization or something. All right, let's take a look at part 2. Enough speculating. All right, as it turns out, You got the else plan backwards. They actually want to know how many recipes appear on the scoreboard to the left of the first recipes whose scores are the digit from your puzzle input. Ah. SMAP says part 2 for me is slower than I'd like. So we have to keep searching through the array that I just made until we find this sequence of digits. And it says how many recipes appear to the left. It just means, what's the index of the first digit that goes 939601. Now, I don't know if there's any way to speed it up. I guess what we could do is just keep track of what we searched up to, right? We can find the first 9, for example. Or, as we're going through, we could just keep a rolling total. Now, here's the thing, right? 14. The interesting thing I want to note is that this logic is going to be useful for part 2 also. It only takes 32 milliseconds to run part 1. The question is, do I want to try to save what we've generated so far and then just, yeah, we could do that, right? What we could do is save the recipes here, which is just a vec. Let's just use the same type. It's a vec of view size, but it could just be a vec of view 8s, right? Doesn't have to, I don't want to consume all that much memory. Recipes. It just means we have to just as U8 everything, which is fine. Vec of U8. And then at the start here, we'll just say self recipes equals vec. Bang. And now let's see if Rust can infer the type of this number. No information available. I was hoping it would be able to do that. And then we just changed all of these to self recipes. And that way we have all the information and we can start part 2 by just looking for that sequence of digits. ICS Boix. Hello. Alazi? I don't know what Alazi means. Hopefully that's not a curse word in some foreign language that I'm not aware of. So what we can do, that's the thing, right? It might be easier to just keep a running value and look for it. We can make one assumption that it's not going to be in the first 93,000 entries. That's one assumption we can try to make. We could try. So here's what I was thinking is, right, as we know that this is going to be, we know it's 6 digits long. So we can just keep a running total of the last n things we pushed and see if it's right, but we'd have to do it here and here. I'm trying to find the optimal way to do it. Maybe that's not that good. What I could just do is start here with a find. Oh, yeah, I don't want to assume. Let's break this down into its component digits. And we can do that with just a simple vec of U8, right? New. Oh, I have to do it this way, right? Oh, I forgot to change these to self. Right, and then we can just grab all the digits for D in. Oh, it's backwards. That's okay. We can reverse it, right? Yeah, we can do it. Let mut num equals self recipe count. Ooh. Right? And then we can say while num is greater than 0, digits dot push num mod 10 as U8, and then we say num divided by equals 10. All right? And that should give us all of our digits. Oh, I don't know if that's going to work. I can fix that one, and can't add U8s. Oh, yeah, we can do it this way though, as U size. There you go. And then digits, we can't do that, so we can say format, bang, digits, like that, right? And I forgot to close the delimiter. 106939. Yeah, and it's backwards, as was foretold by the prophecy. Digits dot rev equals digits dot iter dot rev. Can I do that? Collect. We can't iterate over. Oh, we can't collect into, yeah, we have to map it, or copied. Void Machines, thank you for the follow. Into iter. Blam. Okay, now we have the digits. So now we just need to find this sequence of digits in recipes, and it's probably not going to be there. So we just have to keep doing this loop here until we find it. So maybe I'm going to extract this code out so we can call it from both places. I don't know if it's worth, it's probably more work. It's probably easier just to brute force it and regenerate the recipes from the start. But I'm doing it this way because I have time. So we can do a find, right? For, there's a way to do a find, right? Self, we could say location in self recipes dot iter dot find, right? We can do a find. Find takes a closure, returns true or false. It applies this closure to each element of the iterator. If any of them return true, find returns some element. It will stop processing as soon as it finds it. Okay, so we want to actually filter all the first digits of digit, and then see if the subsequent digits are the ones we need. So we want to iter enumerate filter on. I think I do this right. IR for recipe. Oops. And then if R is equal to digits of 0, collect. Oh, we're doing a for loop. So that might fit all there, right? And then that's a U size U8, and we don't care about the U8 part of it. So we can say, because we know it's going to be the digit we're looking for. So now I should be able to print out at lock IC, and I want to just do self recipes of lock dot dot digits. Lock, is it lock plus digits len, right? Why is that not highlighting for me? What am I missing here? Oh, I'm missing that. Oh, there we go. That's why it wasn't highlighting. Okay. We can't compare ampersand U8 with U8. Lock is usize. Lock is usize. Digits len is usize. Oh, it doesn't know the length of the slice, so it can't print it. It won't let you do that. You have to know the size of the slice at compile time. And I kind of do, because len is fixed len, but Actually, if I put a constant in here, will it know? If I put 6, will it know that the size is known? Because it's definitely a size of 6, right? But it can't figure that part out. That's a shame. I guess what I could do is I could say iter collect and just make a vec out of it. I don't know if there's a smarter way to do it. There probably is. Now it's computing and it's not finding anything. So that's a shame. So we're going to have to kill it. Cargo run. Oh, wait a minute. Okay, so it was working. It was just dumping out a lot of output and Bacon wasn't happy with it. So I'm looking basically for all the 9s and seeing if it finds the sequence that we're looking for. Now the question is, can I do this? Instead of printing it out, can I compare all the digits? If, I can say for D in digits, if D, what type is D, is equal to self recipes of lock plus enumerate ID. I think I still needed the star on that. Digits iter enumerate. Yeah. Of lock plus I. If it's not equal, then we're going to say continue next. Right? And then if we get all the way here, then we found an answer. And so we can just say return lock. Create output lock. And that's not going to work, right? Because it's not in the first n. Oh, why did I do that here? I'm not thinking. Piyush Karuna, thank you for the follow. Welcome. All right, so if I say cargo run now, it won't generate a ton of output, but it doesn't find the output I'm looking for, right? So now we have to continue, and that's where we're going to refactor this bit. Fun step, stemp, mod self, doesn't do any output, and we're going to just do this, boom, 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 boom. Oh, I have to pass in the elves. Or put the elves in here. Elf 1 usize, elf 2 usize. And then we can just do that here. Self elf. Oops. That makes this thing really long. And then we can just say step, self step, like that. And we should still have an answer for part 1 with this, except I have to use the self here and here. Oh, that broke it. Oh, because I need to start my elves off. Gotta start my elves. Self.elf. And now let's try it. Mighty Core, thank you for the follow. I think that's right. 583, 287, blah, blah, blah. Yep. Okay. So now we just need to do this thing here. I guess we could run it a few more times. Here's the thing is that now we need to figure out where we left off and start searching from the previous 9. Yeah, this is a lot more complicated doing it this way than just starting from scratch, right? Let mut last lock 0. last lock equals I. Why does it think I'm not using I? I'm going to get rid of the println because it's making things ugly. Oh, lock. That's it. There. And now we're going to start from last lock and look in that direction. I guess we could do 9 at a time, or digits len at a time. Just keep adding those. We'll end up adding more than we need to, but maybe we should keep adding until we have a 9 at the end. Oh, I'm also making an assumption here that there's no 9 close to the end. Yeah, I think I'm overcomplicating this thing. I think I just want to generate more codes. But here's the thing. I think I'm just, I'm trying to do it the smart way, and I don't think it's worth doing it the smart way. I think it's just easier to keep track in part 1, and then we're done. All right, so I think the best thing to do is, instead of trying to be clever about this, is to just keep it running. We've established the fact that the sequence we're looking for is not going to be in it's not going to be in the part 1 section. So we can just go from part 2 and just do a step at a time and then look. I guess what we can do here, because again, I was worried about going too far into recipes. We can say if lock plus digits, and let's just save digits len, since I seem to be using that everywhere. Lock plus len is less than self recipes len. Then we can do this, right? Otherwise return that, right? If we hit the end, then we didn't look at that last lock. Okay. The only thing is that we need to skip. Yeah, that's not going to be fun. What we can do is start a rotating, right? We can start a rotating list of however many digits there are. So let's put our digits up here. And that way we know how many to save, right? And then we can say, instead of self recipe count, well, we can just build it this way, right? Right? And then we're done here. That should still build. Oh, we don't have len anymore. Let len equals self digits len. Deleted too much. And this should be self digits. There we go. Mohad, hey, how are you? You can clone this value. I can. You're right. How does that help? Oh, okay. I can't do it that way anymore. So what we can do is just let mut digits equals vec new. Right? And then we can just do this way. And we're not using I. Yeah, so now that we have this, we have the digits, we know how many digits we need to be looking for. And what we can do is we can just push those digits here, right, as we generate them. Last n, evacuate. Oh, I missed a comma. So what are we doing? We need to say, when we push thing on here, we want to say here, if last n, last n.len is less than digits len. Last n dot push back 1. Right? And then we do the same thing here. Actually, we want to do it this way. Self last n pop front. And then we always want to push back. Right? Grab those, put those here, and then we push back, same thing here. Like that. It's a little bulky, but it should do the trick. And then we could just compare last n with the last n with our value. And that should give us our answer. Now what blew up? This, we need to grab it. Self digits. And then last lock is no longer used. So now we don't need to, for part 2, we don't need to do this. We just need to keep looping, right, until... Right, so now we got to keep stepping until digits is equal to the last n. And I don't know if that's going to work, so I'm going to quit out of this again. If let's see if we can even compare this. Self digits is not equal to self last n. I don't know if you can compare vectors like that. Self step. Self digits, and then we can just do this here. Can't compare VecU8 with standard collections something. Oh, because one's a... that's a shame. As slice. Make contiguous. That's going to be super slow, but at least you can compare them that way. So I've got it running 7 times faster. Oh, neat. What'd you do? Mine is running 7 times slower. Let's try release mode. Somebody said I was using a linked list before. Oh, okay. Yeah, I'm just using VecDeck, and for some reason it's taking forever to build. This happens sometimes. Like it just gets stuck. And even release mode is terrible. Okay. So this comparison thing is not the best way to do it. I guess what we can do is loop. We can say loop and then say for can I do this? AB in self digits iter zip self last n iter, right? And then say if A is not equal to B, then continue next. Right? Otherwise, we found our answer, which is the same thing as this thing here. Oh, no, well, our answer is our current location, sort of. Println self recipe minus self digits. Right? Not println, return. We got something. Okay, so it found it. It just took a minute and a half to find it. And that was in release mode. It found it. And of course, because I only printed out the fact that the arrays were equal, meant that we didn't get the answer we were looking for. So let's, what we should do is just look for this. And we should be able to see it. We should see it say 9, right? Let's try that. Unreachable expression. What did I do wrong here? Oh, that goes there. And it's still not happy with it. Oh, that's unreachable now. Okay. And line 69, we don't want that. Oh, we don't have to ASUate it? Okay. Yeah, we're all good. Cargo run, release. Yeah, I think one of the reasons it takes forever to build that last step is because it's building all of the solutions to all of the years. So this map says I still need to refactor day 6 to get part 1 to run about 40% faster. You have a 1 second limit for any part. Okay. Well, as soon as this is done building, I'm going to try my day 6 and see what that looks like. Moonlighter says, what's AOC? If you do bang AOC in the chat, it'll give you a link. There's also a link in the description. All right, so this is 2A3137. Is that right? No. Oh, because I'm assuming it's not going to happen. I'm assuming it's not going to happen in the first part. So how long is it here? Println self recipe len. Let's just see how long it is. Let's just do this because that'll build faster. 51599 long. And this is 51589. How about 92510? That appears after the first 18 recipes. 92520. Oh. Yeah, so it's not gonna I can't use it this way. I'd have to restart the recipes from scratch. Which we could do. Fn reset mod self. That's not going to change. So it's just these three numbers. Right? And then last and clear. Maybe, just to be on the safe side. But digits doesn't change. Yeah, let's try this. Self reset. Right? And then I can do a self reset here. Oh, all right. It has to go up here. And why did that fail? Because it found it? Oh. Because the digits yeah, I have to at least assume, I have to run it at least digits times. right? 18. I think that was correct. 18. Yeah. Okay. And then 59414. Appears after 2018. And the reason he did the 2018 was that, yeah. Okay. Now we can get rid of this print. All right. So we're just doing all the work. That's fine. It still takes forever, which is a shame. But now let's use a real input. And what did it take? 90 seconds to run? Oh, Pedro. Pedro says, sorry, I missed Smab saying, might as well restart because the starting portion is insignificant. Yeah, I'm finding that based on how long it took to do part 2. Pedro says, which monitor do you use? I actually have a couple of monitors. I have a Dell monitor that I'm using for my display for streaming, but then I have a 4K Samsung monitor off to my right for everything else. Oh, so you got it under your 1 second limit. Nice. And Pedro, thank you for the follow. I'm about to wrap up here as soon as we get the answer for day 14, part 2. And then I'll have to think about, maybe I'll make a rare Saturday stream. Normally I only stream Mondays through Fridays. But next week is mostly a holiday in the States. Many people take the whole week off. Some people take most of the week off. So I'm thinking maybe I stream tomorrow to do some work. Polar Mutix, thanks you for the follow. Seems only Ultra Sharps work with Mac OS. I don't know. So I've gotten this is Mac OS. So I've gotten a variety of monitors working on this thing. The Samsung I don't like because it doesn't auto switch properly. I turned on the auto switch, but then when I plug in a different computer and turn off the first computer, it just says no signal, shutting down in 3 seconds, which is absolutely useless. So I'm thinking of putting it on a. Sorry, what am I doing here? All right, we have an answer. Sorry, let's get this going. It took 80 seconds to run, and it's the wrong answer, and it's too high. We were able to get the other answer when I did the test for part 1. When I did the tests with the test input for part 2, it worked. And Smab says, that's not the answer I got for you. Yeah, so you probably got the right one. What would be a reason this would fail? I guess would be a good question. The only thing I could think of is that the 1, right? Because we're pushing an extra digit here. So if I got, for example, the output ends in 601, but if this came up with a 10 or a 12 or something like that, then the last n digits would be 396012. So we can't just check, and that's probably why he has a 1 at the end. Smab, does your puzzle input also have a 1 at the end? So I'm going to cheat because I think that's the bug. Yes, mine is. Yeah. So that's what I think. That's what I think he's doing. It's the edge condition here where you actually have. So I'm going to do this. Right. I'll give it one more digit. And then we're going to iterate over these digits. You know what I can do is test it with this input here, because this ends in 16, right? So I should be able to search for 15891, right? And that should find it. at whatever position that is. 15891. Yeah, for some reason it took 33 seconds to build this optimized. Yeah, if you assume the input has a 1 at the end, you can make some neat assumptions, right? And that's going to be my guess, because that's the only way to make this hard and come up with the wrong answer is to do that double digit thing at the end. 11. Does that seem right? It would be this number here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did I put in? 15891, right? So it should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I said 11, and it should be 10. Right, because we're one past. We're one past it. Because I'm cheating, right? So this says 11. It should be 10. I'll subtract 1 here because I'm cheating. Total hack because I assume the puzzle input ends with a 1 digit, right? And then I can clean this up. Maybe like I said, I can do a stream on Saturday and just clean this up and make this faster. But I just want to get the answer because I got to get to work. Yeah, which means no. It means we might find this answer sooner. Okay, let's hope it doesn't take another 30 seconds to build. It probably will. Epic says it's not cheating if you admit it. There you go. All right, I just want those 2 stars from SMAB. That's what I'm looking forward to. Is everything else good here? SMAB says it's an optimization. That's right. Optimization is a total hack is a euphemism for optimization. Okay, so we got, oh, look how fast it came in because I was able to find it faster. I'm going to run it without debug mode now and see. Yeah, so it takes 2.5 seconds. And that's the right answer. So that's the problem. Thank you, SMAB. I got the stars from you before I put it in here, but you already knew my answer, so that's another optimization.